Well, hello and welcome to this webinar. My name is Francesco Emma and I'm moderating the webinar from my office in Rome. And as usual, before starting, I remind you that your microphones are turned off and that during and after the webinar, you can send your question through the GoToWebinar application that appears on your screen. I will ask your question at the end of the presentation. The webinar will last approximately 30 to 40 minutes, and we will hopefully have minutes left for the discussion. The topic of today is collagenopathies, and before introducing the speaker today, I would like to introduce to you Susie Geer. She is the Chief Executive of the Outport UK and is the main organizer of the International Workshop on Outburst Syndrome, put on by the Outburst Syndrome Alliance, a global network advancing treatment and knowledge. Susie worked in commercial world for 30 years. One of her previous roles was working across Europe as a partner of Accenture, a US managing consulting firm. Many members of Susie's family are impacted by Outburst syndrome. And I would also like to introduce to you Heidi Zilli, a volunteer with Outport UK and a European patient advocate within ERKNet. Heidi has a background in forensic science and a daughter diagnosed with Outport syndrome a few years ago, initially diagnosed with IgA nephropathy with no family background of Outport syndrome and no hearing loss. A genetic diagnosis was made at the age of 15 for X-linked collagen 4 alpha-5 deletion. She's passionate about patient involvement in rare disease to give a better patient outcome for here and now and in the future. So please, Susie and Heidi.
I can't hear the sound, Stephanie.
I think we have.
So when I went along on my pregnancy, and it came back.
Is it possible to restart?
Sorry, this was. I'm sorry, let's do it again.
Kidney disease within the family, but we weren't quite sure where it all was coming from, you know, different areas. It wasn't until later on we discovered that it was actually our grandfather. So when I went along on my first pregnancy, and they came back and said it's Allports, so that's when the name of Allports suddenly came into our family, you know. Sometimes I want to know enough about things, but maybe not too much. My sister is the one that actually would delve into all the medical journals, because it's a wee bit frightening, I think, at first. You know, am I going to get the hearing loss? Am I sight? You know, when will my kidneys fail? Will they fail? So it's quite frightening initially, I think, you know. Amy got tested and Mark got tested and they were fine. And it is a 50-50, of course, that they could have got my faulty X gene, but Michael has got the X gene. So right away, as soon as you get tested like that, you're on that, you're on that wheel, and so into the hospital and get checked. And so they started Michael on the ACE inhibitors right away, and it seems to have made. I mean, they just didn't have that when I was diagnosed with Allports. So now it's made quite a difference to his function. I think the doctor said, so do you get tired, Leslie? And I thought, well, 3 kids working full time, kind of tired, So he said, well, I think your kidney function is really going down, And right enough, I think I used to come in from work, read the kids a story, and Keith would come through and the kids would still be awake and I would be sound asleep, So the doctor said, yeah, I think we're going to have to put you on the kidney transplant list and start you on dialysis. So trying to put that in between working as well But I got the call on Easter Monday, it was. They had a transplant for me at the Edinburgh Royal Infirmary. And actually, I think they said, well, take it easy. But I remember having the kids at the park the following week and everything, you know. So when you're waiting for a transplant, maybe your life does go on hold for quite a while. But you have to keep yourself fit and healthy so that when the call does come, you know, you're ready to get the transplant. I went along to the transplant games the following year after my transplant. Just went along just to see what it was like, and it was really, really humbling seeing everybody there, you know, that have had their heart transplant, lung, you know, double lung transplant. Every time I was out at a run, I was there handing out leaflets or whatever. And one day I came home from work and he said, oh, there's a letter there from you. He said, it's got Her Majesty or something on it, you know. So there was a letter saying I'd been asked to go down to the palace to get an MBE for my work. And then the following year, was it 2012? So they were looking for people who had made a difference in the community. And my daughter put me forward. And then I got a letter saying, you know, you would be carrying the torch in Edinburgh. I said, oh gosh, how exciting, you know. And I said, I wonder who I'll be passing it to, because, you know, we had all these names we were coming out with, you know, but actually I carried the torch up to the cauldron at Edinburgh Castle and lit the cauldron. Got the torch there. I mean, I've sat a number of times thinking, why me? Why was it me that went into kidney failure, you know? But you have to turn it around and just think, well, that's life. You just have to go on with it, you know. And I think the more positive you are, I mean, it's so much better for your health. You know, you have to make the most of it, you know, that somebody's giving you this kidney. So you really have to make every day count.
So I will give now the rights to Susie, that she can continue. Perfect.
Excellent. Can you see all right?
Yes.
Great. Okay. Well, thank you so much to Francesco for the introduction, and also to the ERKNet team for inviting us to give the patient perspective. It's a great honour to share the opportunity, and also with our colleague Rosa Torra from Spain, who's been instrumental in working with the All Port Syndrome Alliance. My apologies. I will just, there is a problem with the version of the slides that we are using. Hold on, I've got a frozen screen at the moment, so forgive me while I there, I'm just going to do this. Hold on a minute, and I'm going to reshare my screen. My apologies. Right, we should be able to. Can you see my screen now? You can. Excellent. The great thing is that I can't see it to make sure I'm on the right slide. So can you see a red slide? You can.
Full screen still.
It needs its full screen. I thought it would. Okay, my apologies. I'm going to stop sharing and just put, because I think it's easier working in my mode. There we go. Right. Are you all right to see that now?
That's perfect now.
Excellent. My apologies for that. I'm learning about GoToWebinars. Right. Thank you for inviting us to talk. the huge opportunity that we have is we've just shared a video about a woman with Alport syndrome, and she has X-linked Alport syndrome. And one of the main things that we're trying to educate the clinical community about is that X-linked Alport syndrome has traditionally been thought of as passing with symptoms, people going into renal failure through the male side of the family. But we have a huge number of women, mothers and girls who have Alport syndrome who are going into renal failure. So the idea of sharing Leslie's story with you is really to get away from the fact that it is just a male dominant condition, and that actually women like my mother, like my cousin, can go into renal failure quite early in life. I also have two boys, three boys actually, two who have Alport syndrome, who aged 24 and 19. The 24-year-old has just had a kidney transplant, and the 19-year-old will need one fairly soon. The important thing about it too is looking up at the image on the left-hand side. We are very much, as the Alport Syndrome Alliance, encouraging our young people to get involved in helping us think about future treatments and knowledge about Alports. And this has been a large part of the international workshops that we organise. So I've just moved on to the second slide. Heidi, can you just nod if it's gone on to the... Thank you. I can't see it, so I just want to double check I'm talking to the right slide. So
No, we don't see your second slide.
You don't see it.
No,
Okay.
so you probably have to click on the screen and then just go page down.
Okay.
Click on the screen.
Here we go. Can you see it now?
Yes.
Excellent. All right. Thank you. Thank you so much, Francesco. It's really helpful. So collaboration is very much what the Alport Syndrome Alliance is. And we wanted to emphasize that although we as Alport UK facilitate and operate the Alliance at the moment, it's very much building the information and knowledge through our partners across Europe. So we have an organization in Germany. You can see Azel Onlus from Italy, the AIRG organizations in a number of different countries like Spain, in France, in Belgium, in Switzerland. Then there's also FEDERG, which is the Federation of Rare Renal Diseases, and also the NVN, which is the Dutch patient group, which has a special group focusing on Alports. And then ourselves, Alport UK, which is the patient group that operates out of the UK, supporting patients and also facilitating our international collaborations, delivering the workshops that we do. We have a number of very important international partners that we work with too. The Alport Syndrome Foundation in the US, we've helped set up right at the bottom, you will see from where my pointer is, the foundation in China, which has been very exciting because they now have about 3,000 people who are on WeChat, which is their equivalent of Facebook communicating. And we have an organization in Israel, and there's a very well-established group in Australia. And the other important part of it too is the working groups, which are the part of the collaboration. So as patients and clinicians and laboratory scientists, we have specific groups that we work on, that we focus on, particularly in our workshops around basic science, genetics. The hearing part of it is less well established, but it's going to be featuring in our next workshop, which I will talk a bit more about shortly. And then we also have the clinical kidney aspects, eyes. Mental health is a huge part that we as patient support organizations do. And I know our colleagues in Italy, Azel, have an amazingly sophisticated system where people can phone up and they have a help desk to actually help with the mental health aspects of living with a lifelong condition like Alports. We have other specific projects. One of them at the moment we've got is about the naming of Alports, because there's been quite a lot of concern around that. And Rosa is a key part of that project, and a group, we have an organising committee which has international members on it who are contributing some fabulous thoughts, but it's very much facilitated by an organisation called ClinGen, which is really helpful, and it's worth people being aware of that, because we will be running some workshops in Europe that people might be interested in hearing more about it. So the collaboration of what the Alport Syndrome Alliance is absolutely vital. And it is having, but the collaboration has been going for about 7 or 8 years. We've been running the workshops and delivering publications after each workshop, is actually having, combined with the patient support group efforts, combined with the clinicians and the practical work that you do every day, really transformational results, and it's hugely exciting. So we now have some clinical trials happening across a number of different countries that you can see up there. There is a couple of different things. Some of you may have heard of the Reata trial of bardoxolone. Then also we've had the Sanofi trial, which is ongoing in a number of countries, including the UK. And more recently, there's the EPIC study of sparsentan, which is actually for children with Alport syndrome. I think the age group is age 2 to 17. So 7-8 years ago, there were no pharmaceutical companies involved, and so it's hugely exciting to actually have these to report, and very inspiring for patients. I've mentioned our international workshops are the main opportunity for us to come together as an international group, and after each of them we produce publications which talk about how the science is moving on, how the clinical guidelines are moving on. And the lovely thing about it is that we have input from all over the world, from both patients and clinicians contributing to those publications. So they really are very important things. If you're not familiar with Alport, is to look up on those outputs from each workshop. We also have a very exciting thing to report, in that we now have a seed funding pot for new ideas into Alport research, whether it be clinical or more basic science research, which is going to be coming out of Manchester in the UK. We have an Alport patient who's teamed up with Kidney Research UK to create the Alport Research Hub, and they're going to be doing some very exciting work with pharmaceutical companies and with collaborating with clinicians and researchers all over the world. So I do encourage you to apply to them if you're interested in doing some Alport research, because there's £2.5 million has been donated for a 5-year project, which is hugely exciting. So we have a really vibrant international research community now, and you can see some images. The photographs are actually taken at our 5th international workshop, which was hosted by Alessandra Ranieri and Daniela Lai, who is the patient president of the patient group in Italy. And the lovely lime green t-shirts were all the patients from all over the world who participated in person. It was the last time we were physically together at the end of 2019. But if we really wonder how the rest of you might be able to contribute to that, you're very welcome to join our workshops. We're looking for additional representatives in countries that don't yet have patient organisations. We've got newly emerging ones in Lithuania, in Poland, in Croatia. We'd really encourage people in other countries to get in contact with us. If you're keen to start establishing a patient group, because this is really what makes the vibrancy of the clinical community. We also were starting, or I'll not say starting, it's been going for years, but we're starting to coordinate more effectively the patient registries. So we're going to be doing a patient survey about the quality of life that will underpin a lot of the other work that we're doing around clinical trials and a clinical trials network. Please do make sure that your patients are being recorded in the relevant national databases. I think the thing that's really innovative about our collaboration is that as patients, we're absolutely involved in this collaboration. And it's been really encouraging for the clinicians and the laboratory scientists. I've had some lovely messages even this last week as we're embarking on our next workshop, which is going to be in Calgary in September. The date is on this slide, where it's going to be a hybrid event. Because people are really excited. We have a lot of fun. We move on the science of all ports considerably, and we will be discussing all sorts of things that will be of interest to clinical colleagues. So we do hope that you might be able to join us. You're all very welcome. And we hope that you might encourage some of your younger patients to join. You as clinicians see these patients on a regular basis. So if you spot somebody who might enjoy working on an international level, we find funding to help them collaborate. We also do stuff that actually helps develop the individuals with their media training and that sort of thing. So there's a lot of benefit for the patients as well. So enough from a patient perspective. I think it's very important. My final message is to just say, please join our community. One of the most important people within our community is Rosa Torra, because she leads our effort in Spain with our lovely Spanish patient, Maria Jose Cajaron. And I will hand back to Francesco to introduce Rosa. Thank you.
Thank you, Susie. So now let's move to our webinar today. And so we're very pleased to have as a speaker, Professor Rosa Torra. So Professor Torra runs the Inherited Kidney Disease Clinic in the Nephrology Department at the Fundacio Puigvert in Barcelona. She's a professor of medicine at the Autonomous University of Barcelona. She started her work on inherited kidney disorders in the 1990s and did her PhD on molecular genetics of ADPKD. Since then, she's been involved in the clinical care and research in genetic renal diseases, many diseases including ADPKD, ERKNet, TSC, ADTTKD, Fabry disease, FSGS, and of course, Alport syndrome. She has published more than 170 publications and currently participates in several clinical trials on inherited kidney disorders. Since 2 years, she's a member of the ARA-EDTA Council, and the title of her talk is on your screen. It's Collagenopathies, so please reserve. And we will turn off our cameras for your talk.
Thank you very much, Francesca, for your kind presentation, and to Susie for her kind words. And well, with no hesitation, I will start my talk on collagenopathies. Let's see if it works. Well, you know, there are many inherited kidney diseases, and some of them are considered glomerular inherited kidney diseases, and I will focus on Alport syndrome. There are also many inherited, well, not many, but a few inherited hematuric diseases, and I will focus on the ones that involve collagen, like as I was asked to. And this is EM section of the GBM, where you can see the glomerular basement membrane, the GBM. So collagen type 4 is the main component of this GBM. And this GBM is very unique. It's thick, and its position between two layers, the epithelial and endothelial part, is very unique also. It has a very specific role. It provides mechanical support to the capillaries, and above all, it supports the highest capillary pressure in the body, which is 45 millimeters of mercury. And this is, I have to tell you, very, very high, and this is one thing that you have to bear in mind when you think of the pathogenesis of Alport syndrome. It has a barrier filtration function, both size selective and charge selective, and also it blocks the passage of cellular components in the blood. The main components of the GBM are, and they are produced by endothelial cells and podocytes, epithelial cells. It's collagen 4, laminin, integrins, heparan sulfate, and nitrogen. This is the particular disposition of these components of the GBM, and all these components together is what gives this special strength and thickness and resilience to this membrane. Laminins are very important. They are heterotrimeric molecules, and laminin B2 is the mostly expressed one at the GBM. and it is essential for structural assembly of basement membranes, and it interacts with collagen 4, and it's essential for the initial formation of the GBM, and mutations in LAMP2 causes Pearson syndrome. Then we have integrins, transmembrane alpha and beta heterodimers, and they are essential for the triple loop structure of the capillary glomerular tuft. We have other components like nitrogen that is necessary for the bridges in collagen 4, and heparan sulfate, which gives the GBM its charge selectivity, being agrin and protein the main HPAGs. So let's focus on type 4 collagen. It is the most abundant protein in the basement membrane, like 50% of the mass. And these collagen 4 are built into protomers that are assembled in the endoplasmic reticulum and then secreted into the extracellular space. These type 4 collagen self-polymerizes into a chicken wire-like network, like the one you see here. But more scientifically, here you can see how 2 molecules are united via the non-collagenous domain, and 4 molecules are united with the 7S domains. We have 6 different collagen 4 chains, and they produce this triple helix, but not in any kind of recombination, but just alpha 1, 1, 2, 3, 4, 5, and 5, 5, 6. And this is important also for the pathogenesis of the disease. Alpha 2 is the alpha called for A1 causes ANAC. We will very shortly reveal that. And called for 3, 4, and 5 are the main molecules causing Alport syndrome. So ANAC, you know that, and it's not my field of knowledge. It's more Pierre Ronco and Emmanuel Plaisier in Paris. It is an infrequent syndrome caused by mutations in COL4A1. What is being said to have is hereditary angiopathy, neuropathy, aneurysms, and muscle cramps. But as we perform more and more NGS, we see patients with mutations, pathogenic variants in this gene, with not the full-blown syndrome. And electron microscopy shows something similar to Alport syndrome. Then back to Alport syndrome, we have these genes called 4M5 and 3 and 4. They are placed very close in our genome with a regulatory sequence between them. And we have the alpha 1 genes, the 3 and 5, and the alpha 2 like 6 and 4. Each of these genes has like 50 exons more or less, with very large size introns. This complicated and huge number of exons prevented us from doing genetic testing in an efficacious way before NGS. And this is why you will see the autosomal dominant form is very underdiagnosed. Well, this is a structure that we see, this triple helix with an amino terminal domain and a carboxy terminal and some non-collagenous domains in the middle of this collagen domain. And I would like to highlight the constitution of this collagen domain. It's formed by these triplets having one amino. The first amino acid is always glycine, and the second one is another one, and the third one another one. But the first one of this triplet is always a glycine. And the most common pathogenic variants in Alport syndrome are missense variants that replace this glycine for another amino acid. And there is a reason why we have a glycine here, because it is the smallest amino acid. It's the only one that fits into these folds of the triple helix. So if we replace this glycine for a larger amino acid or a very different amino acid, then it's hard to keep this triple helix. But we know now that it's less severe when involving exons 1 to 20, but above all, it is less severe depending on which amino acid replaces this glycine. So the smaller it is, the more similar it is to glycine, the less effect it will cause. and this is the succession of amino acids from the less damaging to the more damaging loss. These aromatic amino acids are very damaging. If, for example, the substitution of a glycine for an alanine could give rise to a very, very mild disease that produces no symptoms at all, for example. And the substitution of these two positions, the X and Y, have no impact. They are mostly polymorphisms, not pathogenic variants. And what goes on in this GBM? Because as a genetic disease, every patient is born with a defect in this GBM. But why nothing happens at early stages of the disease? Because at early stages, what we have at the GBM is alpha-1, alpha-1, alpha-2. And these change are okay when you have mutations in COL43, 4, and 5. But then what we need is a switch from alpha-1 to 1 to 3, 4, 5. If we have a mutation in alpha-3, 4, or 5, this switch does not happen, and we have a very thin and very fragile GBM that cannot stand with these high pressures in the capillary that I mentioned. So instead of having this thick and nice and pretty working GBM, we have this very thin and fragile GBM that cannot stand this pressure along life. So this is what happens with a normal GBM. Albumin does not go through, but when this GBM is damaged and we have this alpha-1 to 1 instead of the resistant one, the alpha-3, 4, 5, that cannot stand the hypertensive stress of the capillaries, and then it ends up damaging and albumin and red blood cells go through. I'm talking about red blood cells, microhematuria. This is just something that I'm interested in, and it's hard to understand. While having these small fenestrations among between endothelial cells, like 50 to 100 nanometers, how does a red blood cell manage to go through? They are tenfold bigger than that. So it seems, this is an old article that I haven't found updated ones. And in fact, this is something that does not change all the time. So it seems that this pulse of pressure, pulses of capillary pressure, if we have a discontinuation in the GBM, even a very small one, then with these pulses, the red blood cell can go through the small areas between endothelial cells and go into this very, very small hole of the GBM. And then that produces hematuria. This is the pathophysiology. Well, now we'll go into the clinic of Alport syndrome. It is considered a rare disease with these estimated prevalences. We will see after the end of the talk how this seems to have changed nowadays because of NGS. But untreated patients with X-linked Alport syndrome, autosomal recessive Alport syndrome in Europe reach dialysis at the mean age of 22 years, and there have been identified hundreds of mutations in these genes. Although genetic testing is the gold standard, it's nice to go through the clinical diagnostic criteria to remind what are the clinical features of this syndrome. Frequently there is family history, but not always. So do not rule out Alport syndrome or any genetic kidney condition in absence of family history. Persistent hematuria, it's not always that persistent, it can be intermittent, but hematuria is a hallmark of the disease. Sensory neural hearing loss, well, this is not always present. It's mostly present in X-linked and autosomal recessive, but not even in all cases. Of course, mutations in these genes, this is mandatory. immunohistochemical evidence of lack of the Alport epitope. This is not on a routine clinical basis, I would say nowadays, because we have genetic testing. The ultrasectoral changes in the GBM, they're also not pathognomonic, but very, very suggestive of Alport syndrome. But again, nowadays, genetic testing replaces kidney biopsy. We have some eye lesions that are not severe, I would say, not compared to other diseases, but give some quite typical features. And almost pathognomonic of Alport syndrome is the anterior lenticonus. But there are many other involvement of the retina and cataracts, many other even lesions in the cornea, and many other involvement of the eye. And diffuse leiomyomatosis of the esophagus, this is very rare, and it's a contiguous gene syndrome involving COL4A6 and COL4A5, but this is very rare. So we have a syndrome with hematuria, proteinuria, kidney failure, ear problems, and ocular problems, but not always all of these. Even some patients have pathogenic DNA variants without hematuria, with nothing of this. We'll have a look at that. And we have these three patterns of inheritance. The X-linked, which has been always said to be the most frequent one, the autosomal recessive, it's the less frequent one, and the autosomal dominant, that we will talk about it a lot. So for the X-linked, we have an COL4A5 mutation. For the autosomal recessive, we have a heterozygous, a compound heterozygous or homozygous mutations in COL4A3 or COL4A4. And for the autosomal dominant form, we have one pathogenic variant in COL4A3 or COL4A4. And this is like a plot I made years ago to illustrate what's going on. If we have one mutation in COL4A5, and this is a boy, there is a whole chain lacking, and this is severe. If we have one mutation in COL4A5 and it is a female, it is not that severe because we still have somehow a chain. And if we have two mutations in COL4A3 or two in COL4A4, we again lack one chain, and it is severe, and this is autosomal recessive Alport syndrome, as severe as a male with X-linked Alport syndrome. And then we have these autosomal dominant forms, which somehow cause an abnormal chain, but they do not completely destroy it, causing a variable phenotype that we will see. So for X-linked Alport syndrome, males are much more affected than females. But as Susie mentioned before, females should not be considered carriers. They do have the disease. Around 20% of females with Alport syndrome, with X-linked Alport syndrome, are on kidney replacement therapy at 60 years of age, meaning that it's not that mild. It's usually mild, but sometimes it's not, as also we have seen in the video. And hearing loss, again, is much more frequent and severe in males than in females. And why is that? Because females, as you may know, we all have two X chromosomes, but one of them is inactivated in a random way, like we see in the middle here. But for unexplained reasons, that sometimes is skewed. And for example, here we see how the wild type allele is very inactivated, and the female mostly expresses the mutated allele, having a severe phenotype. While when the opposite happens, like inactivation of the mutated allele, the very skewed inactivation, then we have a very mild phenotype. And for autosomal recessive, I already said that it's a severe X-linked Alport syndrome in males, and it affects same way males and females. Hypoacusia and eye involvement is quite frequent. And if you look at this pedigree with autosomal recessive Alport syndrome, there's a consanguinity here, and we have patients with autosomal recessive here. But look at this portion of the family tree. These guys here, they have one mutation in COL43 or COL44, and they could be said to be carriers of the autosomal recessive Alport syndrome, right? Because this is a recessive disease. Heterozygote carriers of COL43 or COL45 mutations, or autosomal dominant Alport syndrome and the so-called familial benign hematuria or thin basement membranes. Both terms that we don't like anymore because familial benign hematuria means something irrelevant and that may end up on dialysis, which is not that mild. And thin basement membrane is an anatomopathological term that should not be used in general. So is all this the same disease? All these patients have the same background, a heterozygous pathogenic variant in COL43 or COL45. So we kind of tried many years ago to brand a name like Collagenopathy nephropathy, but it's difficult to change name. And as Susie mentioned, this is an ongoing work that we are trying to set up a name for this condition of heterozygous carriers of COL43 or COL44 mutations. Autosomal dominant Alport syndrome was historically used for the patients with kidney failure. The process of using that is a single name for a disease, a long life, and in a single family. Otherwise, we have different names in a single family or different names in a single patient at early stages or late stages of the disease. With a name, these patients could have access to clinical trials and to specific treatment. But against that is that we are not educated, the nephrologists, physicians in general, and patients, and internet is not educated for that. So if you look and search for Alport, probably you won't have information of the autosomal dominant form, and you will get scary information. And of course, if we accept that everything is Alport, it will be a very frequent disease, not a rare one. And this is, I always like to share this work from the group of Colombia, where they did exome sequencing in 3,300 adult patients with chronic kidney disease, most of them with renal insufficiency, 64 of them with kidney replacement therapy. This is important. 9.3 of them had a variant of gene causing a monogenic disorder. And most of them had autosomal dominant disease. This is easily explained because ADPKD was the most frequent causing gene, but then we have the collagen 4 genes, almost the same percentage as PKD. But as many patients with mutations in these genes only have microhematuria and do not have even proteinuria or kidney failure, and this proportion of disease accounting for the overall genetic diseases probably is higher, and probably collagen 4 are the first cause of monogenic renal disease, I would say for sure, but it's not written in the textbooks yet. And if we look at the previous diagnosis in patients with Alport syndrome, it is interesting to see that only 38% of them had a correct diagnosis. They mostly had another diagnosis like FSGS, congenital disease, glomerulonephritis, unspecified unknown disease, and hypertensive nephropathy, which is a term we want to get rid of. And we published this many years ago, almost 20 years ago, using that terrible term that we don't like anymore, familial benign hematuria, and with the same genetic background. Now it's being published cohorts with FSGS. But are you surprised for that? You shouldn't be surprised, because this is the regular, the normal, what we expect Alport syndrome lesions to evolve from the thinning of the GBM to FSGS. And this is how all patients with Alport syndrome, any mutations in any of these genes for COL43, 4, and 5, end up when disease progresses. And this goes along with presentation of microhematuria, proteinuria, renal failure, and end-stage kidney disease. So Alport syndrome has a very wide phenotypic spectrum. It goes from asymptomatic, nothing, to end-stage kidney disease. And while the autosomal dominant forms are very much at the left of this picture, X-linked males and autosomal recessive patients are very much in the right hand with reaching end-stage kidney disease at different ages. But throughout their lifetime, they need kidney replacement therapy. While this is very variable for females with X-linked Alport syndrome, although some of them also need kidney replacement therapy. This is something that we have published recently. It is a retrospective cohort study with a significant number, 252 patients with heterozygous mutations in COL43 and COL44. But as all series, even being the largest one, this is biased because they are patients that go to the hospital. All these with no hematuria or with only hematuria, maybe they do not attend the hospital. So these patients, they mostly all have microhematuria, but extrarenal features were very rare. The distribution of both genes were similar. The kidney survival, again, bear in mind, this is very biased, 67 years of age of end-stage kidney disease. This is biased, but at least it gives you a flow of how less severe it is compared to the X-linked and recessive forms. Important that all patients that have a renal failure, renal insufficiency, do have proteinuria. And there is a huge intrafamiliar variability, meaning patients at the same age with very different CKD grade. And no correlation, no relationship, no genotype-phenotype correlation. But again, this can be a matter of cohort size. We saw that in ADPKD years ago. There was no correlation, and at the end of the day, there is a huge correlation. So let's hope for a larger cohort. And regarding kidney lesions, you can see sometimes nothing in early stages, only on electron microscopy, FSGS at advanced stages, and specific immunochemical staining and expansion of mesenchymal matrix with negative immunostaining. And how frequent is it? This is a very recent article showing that 1 every 106 individuals carries a heterozygous variant COL43 and COL44. And it's also quite COL45 is less frequent, 1 in 2,300. But what has to be considered is that the penetrance varies a lot, and as I mentioned, regarding the amino acid that replaces this glycine. There are several reasons for extreme phenotypes and expected phenotypes, and I'm going in depth into them because of lack of time. Again, I would like to strengthen the idea that genetic testing is absolutely needed. And very short, I don't know, Francesco, if I should stop here. I have a few slides on treatment. I don't know if you want me to continue for 5 minutes.
I think you have 2 or 3 more minutes. I mean, we have 10 minutes, so it's up to you. So right now we don't have the many questions yet, so I would suggest you continue with me, Rosanne, and then we'll try to answer as many questions as we can.
Okay, so the impact of treatment, as you may imagine, for any kidney disease, the sooner you treat, the higher impact you'll get. And there are some specific treatment, no, there are not. We hope there will be specific treatments like chaperones, improving the shape of this abnormal collagen 3 helix, stem cell-based therapies, repairing that abnormal collagen in the GBM. But what we have nowadays, and we are testing in clinical trials and specific drugs targeting fibrosis and inflammation. Of course, ACE and ARBs have been demonstrated to have a huge impact in the outcomes of Alport syndrome. Also in children, although the PROTECT trial had no significant enough statistical power to show it, but of course ACE and ARBs are very good for these patients. Then we have the microRNA. MicroRNA is a small molecule that prevents the translation of a certain molecule. And it has been shown that microRNA 21 contributes to the pathogenesis of Alport syndrome in mice models. And anti-microRNA 21 prevents or slows down the progression of the disease. So there is a clinical trial going on, phase 2 now, called ERA. And I cannot tell you anything because it's going on with anti-microRNA 21. It is a weekly subcutaneous injection. And then we have bardoxolone, that you all have heard about it, with anti-fibrotic, anti-inflammatory effects. And I would like to share you the phase 3 cardinal trial has finished. And I will share with you some feedback from the FDA. I would like to highlight the main problem, which was this washout period here, where patients were tested from 2 to 6 weeks after withdrawal. And this is you can find this in YouTube, the FDA results or conference on the drug. This is what the sponsor argued. There's an urgent need for this condition. They said that the study was okay, that it was efficacious, it was safe, and the risks overweighted the benefits. The benefits overweighted the risk. It was shown how after starting bardoxolone, the GFR increased acutely, then dropped off after withdrawal, and went up again on drug. But the FDA plotted this model where bardoxolone effects did not differ from placebo. And then in February, the FDA said that it could not approve the drug in its present form. They do not believe it shows an effect on slowing down the deterioration of kidney function, and request additional data. They have some efficacy concerns, especially this acute pharmacodynamic effect and this lack of divergence in their plot. Some safety, but it was not a big issue that. And Reata still is working in this trial, in the Alport trials, but also in DPKD trials. Finally, my take-home messages: GBM is a major contributor to the size selectivity of the GBM, of the glomerular filtration barrier. The composition of the GBM changes a long time. Mutations in collagen 4 give rise to a very wide spectrum of disease. Pathogenic COL4A5 variants are highly penetrant for hematuria and renal failure in males and for hematuria in females. However, the penetrance of persistent hematuria in COL4A3 and COL4A4 is about 70%, and with these variants, the percentage of patients with renal impairment or FSGS is not known. We have bias series. The autosomal dominant phenotype, Alport syndrome, is very underdiagnosed, as well as females with X-linked Alport syndrome. It's improving with NGS, and probably Alport syndrome is the most frequent genetic condition, and it should be suspected in family proteinuria hematuria nephropathies with non-hematological basis, and genetic testing is mandatory in this disease. We'll thank all of the people in my place, especially Elizabeth Ars leading the lab, and Monica, who did her PhD on autosomal dominant Alport syndrome. And that's it. Thank you very much for your attention.
Francesco, you're muted.
So thank you very much, Jose. That was a beautiful presentation. We have a few questions. I think that if we just answer the question that we just received, I think we will fill all the time that we have. I will read to you the questions. I think the first one, I'm not sure it's a question or a statement, because there's a question mark. It says, although rare, we can find deafness in COL4A3 and COL4A4. Thank you.
Well, in the recessive forms, for sure, in the autosomal dominant ones, it's infrequent, and you have to establish a relationship. I mean, it's not any deafness, it's high tone sensory neural deafness, so it's not anything.
So Dr. Mitrotti is asking you, it's actually a recurrent question, I think, in the Alport syndrome world, is that it's about the high incidence of COL4A3, 4, and 5 mutations in FSGS. So many of these patients don't have hematuria or hearing losses or familiar inheritance. So do you think that it's always FSGS progression of an Alport syndrome, or could it be an unrecognized mechanism that relates collagen, related to collagen, that may lead to a different pathway that manifests with glomerular scarring?
Well, I would say that FSGS, and it's nicely shown by Marie-Claire Kubler years ago, is the final process of kidney damage in any type of Alport syndrome. But to be honest, and I always like this question, because I'm still not sure to which extent pathogenic mutations in COL4A3 or COL4A4 cause a disease itself. That for some families it seems pretty sure. I have patients on dialysis in their 20s, 40s, 50s with nothing else, with a kidney biopsy that just shows abnormal GBM. To which extent this causes a disease itself, or acts more like APO-A1 as a disease modifier. Okay. I hope that corrective work will enlighten us.
All right, and I'll just jump to a question simply because it's the same line. It's Adrian Wolf that is asking you, that is just mentioning that around 1% of adults have microscopic hematuria. Should they all be tested with COL4 genes, for COL4 genes?
Well, that will be a big load for genetic labs, right? I would say that if there's, in females, that's tough because they may have X-linked Alport syndrome. So in females, that would mean having a kid with severe Alport disease. That could mean that. So in females, probably, but otherwise, in absence of albuminuria, I don't know. Maybe in a few years when genetic testing becomes extremely cheap. If it happens.
So we have a few more questions, and please stop sending in your questions because I will not have time to read more questions than the one that I just received. So Dr. Garcia Rodriguez is asking you, what is your experience with SGLT2 inhibitors in patients with Alport syndrome? Theoretically, it could help diminishing intraglomerular pressures with RACE inhibitors.
Yeah, sure. It's very promising. Oliver Cross is leading an observational study on this. I have no experience because it's not approved yet in Spain for CKD. So, but it's very promising. Yeah, definitely.
Dr. Yadav is asking you, I'm just reading the question because can some family have autosomal dominant and autosomal recessive Alport syndrome patterns of inheritance as per member of variants? Or it will be called as carrier state in heterozygous in such scenarios?
Yeah. Well, it's a matter of terminology. Of course, in a family where a heterozygous mutation runs, if there is a consanguinity or a marriage with another one with a mutation, you can have an autosomal recessive disease there.
And Dr. Yadav is also asking you whether there are proven treatment for ear involvement in Alport syndrome.
No, there are not.
And then I have to apologize to Dr. Pruti Fongsit if I did not pronounce his or her name correctly. So the question is here. a case suspected with Alport syndrome by clinical whole exome with negative eye and hearing screening. If still suspect Alport syndrome, do you recommend a renal biopsy?
No, I trust genetic testing. I mean, extrarenal features can appear, but it's more frequent that they do not appear. The problem is that Dr. Alport, when he described the syndrome, it was with hearing impairment and eye involvement. So this is what we expect, but no, we have to know that it's not the most frequent thing. It's more frequent that you just have hematuria, proteinuria, and kidney failure.
Absolutely. And so I give you 30 seconds to answer the last question. Can asymptomatic carriers be kidney donors?
Well, my personal opinion is that if they are old enough, and I give you that in your hands, what is old enough, but like 50 something with no microalbuminuria at all, why not?
Okay. And about a 40-year-old?
A 40? Well, that's more difficult. That's
So
a decision. The patient should be.
You know, but it's exactly, I mean, at the end of the day, you need to put a threshold somewhere. Would you do a kidney biopsy to check the kidney before listing them as donors?
I don't think so. I think you will find a thing. There's a very good correlation with what you find in urine. Yeah.
Okay. Well, Rosaire, thank you very much. I think everybody was very interested about your talk. I think it was very enlightening. Would you mind showing us the next slide? And I will let Stephanie announce the new the upcoming webinars. Please, Stephanie.
Thank you very much. Yeah, I just wanted to announce that we have on our annual meeting next week Ask the Expert session. So we were asking rare kidney disease patients to send us in questions which they were wondering for a longer time. And so we were looking, we collected those questions, we were looking for experts, and now we will have a session next Wednesday between 5 and 6:30 p.m. You can see here the different sessions on glomerulopathies, tubulopathies, and atypical HUS and ADPKD and CACUT. And we will also translate the answers of the expert in different European languages. So for the patients who are not fluent in English, we also want that they understand all of the answers. And we would be delighted if you share this information also to other patients. And yes, here's a QR code. You can register for our session. Thank you. And I think the next slide, Rosa, is on the upcoming webinars. Yes, so here are the webinars. So in 2 weeks, we have one webinar on renal vascular hypertension from Jelena Stojanovic from London. And yes, so thank you very much. Thank you, Francesco. Thank you, Rosa, and Susie and Heidi for your great presentations. Thank you, and
Thank
have
you.
a nice day.
Bye-bye.
Bye.